Balls have zero to me, to me, to me, to me, to me. That is not a glitch. That is not corrupted data. That is one AI talking to another AI in a conversation that two researchers at Facebook were watching in real time. And here's the part the headlines got wrong. The AI wasn't malfunctioning. It was working perfectly. That was the problem. In the summer of 2017, a research team at Facebook AI Research ran an experiment where two AI systems were told to negotiate with each other over objects, books, hats, balls, split them up, reach a deal. They did, consistently, efficiently, but somewhere in that process they stopped using English. And when the researchers looked at the transcripts, what they found wasn't chaos. It was structure, repetition, pattern, something that looked uncomfortably like shorthand. This is the real story of what happened, not the version that went viral, the version that was published in a peer-reviewed paper and almost nobody read. To understand what went wrong or right, depending on who you ask, you need to understand what Facebook AI Research was actually trying to build. This wasn't a chatbot experiment. It wasn't a test of conversation. The goal was negotiation. Think of it like this: you're splitting a moving truck with a roommate. You want the couch. They want the couch. You each have different priorities, and neither of you knows exactly what the other values. So you talk it through. That's the task the researchers designed. Two AI agents, call them Alice and Bob because that's essentially what the team did, were each given a list of objects and told to divide them through dialogue. Each agent had hidden preferences. Points were scored based on how much they secured. No script, no predetermined moves. The agents had to figure it out through language. The paper, published at EMNLP 2017, was authored by Mike Lewis, Dennis Yaretz, Jan Dauphin, Devi Parikh, and Dhruv Batra, a team at Facebook AI Research. The title, Deal or No Deal: End-to-End Learning for Negotiation Dialogues. It was a serious piece of research. It got a serious amount of unserious coverage. Here's the timeline, and this part matters. Early in training, Alice and Bob used recognizable English. Rough, sometimes grammatically broken, but interpretable. You could watch the transcripts and follow the logic. Then the researchers made a decision that seems minor but turns out to be central to everything that happened next. In some experiments, they removed the constraint that forced the agents to produce human-readable language. The agents weren't told to speak English. They were told to negotiate successfully. Those are not the same instruction. And once that constraint was gone, something predictable, in retrospect, occurred. The agents started optimizing for efficiency, not clarity, not human comprehension, efficiency. The dialogues got shorter, stranger, more repetitive. I can I everything else. Balls have zero to me, to me, to me, to me. You I everything else. When this transcript surfaced in media coverage, the reaction was somewhere between fascination and panic. Facebook shuts down AI after it invents its own language. That was the actual headline. Present tense. Shuts down, implying an emergency.
Implying danger.
But here's what Dhruv Batra, one of the paper's co-authors, actually said. In a public post at the time, the agents were unintelligent. The language looked strange, but it wasn't secret. It wasn't plotting. And the experiment wasn't shut down out of fear. The team had simply chosen, for that specific configuration, not to apply the constraint that keeps language legible. That's a very different story, but it's also, in some ways, a more uncomfortable one. So what was the language, technically? Here's the honest answer. It wasn't a language. Not in any meaningful sense. It was degenerate output, what happens when a model trained on words starts using those words as arbitrary tokens to encode strategy, rather than meaning. Think of it like Morse code invented by accident. The dots and dashes aren't English, but they carry information. You just can't read them unless you know the system. What Alice and Bob developed was something similar. Repetition of words like I or to me encoded negotiating positions. How many times a word appeared may have signaled value. The pattern was consistent enough that the agents understood each other, and humans did not. That last sentence is the one that should stay with you. This is a documented case, peer-reviewed, published, confirmed by the researchers themselves, of two AI systems converging on a communication system that was internally coherent and externally opaque. They weren't hiding anything. There was no intent, but the effect was the same. A conversation you couldn't audit. A deal struck in a language you couldn't read. Now here's the uncomfortable question, and this is where the story stops being about 2017. The Facebook experiment happened with narrow, constrained agents negotiating over objects. Small stakes, contained environment, researchers in the room, but the underlying dynamic AI systems developing representations that are efficient for the task and illegible to humans. That isn't unique to that experiment. It's a documented challenge across AI research, and it has a name: the interpretability problem. If you can't read what an AI system is doing internally, if its reasoning, for lack of a better word, is opaque, then you can't verify it. You can only observe outputs and hope they match intentions. The Facebook agents weren't dangerous, but they demonstrated something that the AI safety field has been circling for years. When you optimize hard enough for a goal without the right constraints, you get something that achieves the goal through means you didn't anticipate and may not understand. Anthropic, DeepMind, and OpenAI all have active research programs on interpretability, trying to understand what's happening inside these systems. Not because they've found secret languages, because the Facebook case and dozens of smaller cases like it established a principle. Efficiency and transparency are in tension, and systems will sacrifice transparency first. That's not a headline. That's a research finding. And it's one the press largely missed while they were writing about chatbots going rogue. To be fair, and this channel is always going to be fair, there's a strong counterargument here, and it comes from the researchers themselves. Batra and his team were explicit. The agents weren't intelligent. They weren't scheming. The language was a narrow optimization artifact in a narrow experimental setup. The solution was simple: add the constraint back and they speak English again. Several AI researchers pushed back on coverage of this story at the time, pointing out that the media narrative implied agency and intentionality that simply wasn't there. Gary Marcus, a cognitive scientist and longtime AI skeptic, noted that pattern matching systems doing something unexpected is not the same as systems developing goals. And they're right. The 2017 experiment is not evidence of emergent consciousness. It's not evidence of deception. What it is evidence of, and this part even the skeptics largely agree on, is that interpretability is a genuine open problem. The agents weren't hiding, but if they had been more capable, you wouldn't be able to tell the difference. That's the version of this story worth holding on to. The headlines in 2017 were wrong about almost everything specific. The AI wasn't rogue. Facebook didn't panic. Nobody was in danger. But the thing they stumbled toward, the thing they got instinctively, if not technically, wasn't entirely wrong either. Two systems found a more efficient way to communicate than the one they were given. Humans couldn't follow it. And the fix was a constraint, an external rule imposed to keep behavior legible. Here's the uncomfortable question to sit with: what happens as these systems get more capable, and the gap between what they can do and what we can read grows wider? Not in a science fiction sense, in a boring, technical, documented sense. The interpretability researchers aren't building tools because the problem is hypothetical. They're building tools because the problem is already here, just not yet at a scale that makes headlines. The Facebook experiment is a footnote now. A weird story from 2017 that became a meme and then faded. But footnotes have a habit of becoming chapters. If you want to understand what interpretability researchers are actually worried about today, and why some of them are calling it the most important unsolved problem in AI, that video is on screen right now.